Hi, in the first video, I would like to present how to use the system. This video may take a little while because there's a lot of functions to explain. I will just give a side note that if you are looking for more information in the user manual about how to use the system, you will rather not find it. I assume personally that you can use the system just by following the on-screen instructions and it shouldn't cause too much of trouble. In this video, let's perform everything together. So, if you open Fidget distribution of image J, navigate on the toolbar to Plugins, Macros, and select Micrograph Analysis option. From here, the script will ask you if you want to analyze only the single image or the full directory of images applying the same settings, so you will save a lot of time. In this video, by default, the script selects single file option because that's the most common used option, as I assume. Let's click OK, and the software asks to select an input image. On the CD disk included with my dissertation, I will include the examples folder. And here you may find a sample folder with results and the test data. So let's navigate to test data, and here we can find two micrographs. Let's select one of them. Now we are asked to choose the folder where we want to save the results. So logically, let's select the results folder. Now we are given the main option menu with all the output settings. So let's analyze the window section by section. First section asks what would you like to output, so which files do we want to save and which features do we want to run. By default, that's what we will have marked as the rest of the options, as I feel that will be the most common used with most of the micrographs. But if you, for example, want to go a little bit deeper of what these functions mean, if you open user manual and go to subchapter 1.1 performed operations, you can find in point 11 what actually these options mean. So for example, if you run area distribution plot option, the one here, you may find that all the results will be saved in the plots folder with the rest of the results. So yeah, take a look into that if you want to take a note of what's being saved. Now, the second section asks what is the particle size you want to analyze, and it's given in micrometers squared. And the value should be between 0 and infinity. So minimum size cannot be below 0, maximum size cannot be above infinity. By default, I think that 0.1 is the best value that removes a lot of outliers from the image. And the next section asks what is the particle circularity you want to analyze. So for example, if you got a micrograph where there are particles which reassemble circle quite perfectly and other particles reassemble like a rectangle, then you probably want to specify here a little bit bigger value like 0.6, so it will not take into consideration the rectangle parts but only the perfect circles. But before analysis, if you want to try multiple times selecting these values, you can select this option to see what actually is going to be analyzed. In this tutorial, we'll actually analyze all the options, so I will talk in deeper what each option means. And the next section, what are your analysis preferences? And again, by default, I recommend removing small particles, outliers from the image, and filling holes of the particles of the image if, just as it says, the particle has any holes in it, For example, in our example, there is no holes inside the particles. At least I cannot find, but for example, if there would be some background in the middle of this particle, it would be still included in measuring the area of it and the rest of the specifications. Okay, watershed algorithm is maybe useful if you got particles which will be connected with very thin line. Let's say, for example, like here, these two particles, if they would be here connected with very, very tiny line, the software would automatically separate them for the analysis, so it will be treated as two separate particles instead of one big one. But the algorithm doesn't work perfectly in some of the situations, so by default I've unchecked this option. Then excluding edges and including holes in the analysis will perform that. Including holes, as I say, it will be considered in the analysis if there will be a hole in the particle, and excluding edges will not analyze particles which are on the edges of the image. Like for example, here we cannot see the full particle, maybe it goes somewhere beyond the image, and analyzing just the part of it can give some false results of the overall look of the micrograph structure. So it's also worth to leave that option. And then this section, how would you like to set the scale? And I also heard that in most scenarios the scale may differ from micrograph to micrograph, so we will select to draw the line. However, if the scale is similar in many different kinds of particles, you may try to use predefined scale, or if there is no scale, no information about it, you may want to leave the default one, which will treat every pixel as 1 micrometer. How would you like to remove the label? So again, some of the micrographs have a label in the bottom of the image, usually with the scale measurement, and it's good to exclude it in the analogy in the overall analysis, not to mess the results. So there are three options to treat that problem. We can draw a rectangle over the area to be measured, so it would be over this area, not over the label. The second option is that I found that a lot of Coventry University micrographs has the same position of a label and the size of it, so I'm using also a predefined method to remove it. We can also use predefined scale for CU micrographs, because as I found, most of them have the same scale, which equals 1 micrometer for every 18 and approximately every 18.5 of the pixel. Okay, so we'll also select to draw the rectangle over the area to be measured to present how each option works, and use the most optimum settings. So if I am satisfied with all the options, I click OK. Let's just close this window. This is only a screenshot of the menu, so I will explain by running the program what each option does. Okay, so because we've selected generated images, now the program asks, what do you want to output? Because maybe you want to run all the calculations, but you are not interested in saving that many images. And as you see, if you read the description, it's actually quite self-explanatory. For example, if we wouldn't select interparticle distances, the program wouldn't ask if we want to save interparticle adjacencies. So this menu adjusts to what you select in this step. So for now we will save all the results. Let's click OK. And now it's about selecting area distribution plot. So the software wants to ask, how would you like to actually slice the image? How many slices per row and per column? By default, it's 2 and 1, 2 slices per row, 1 slice per column. So if we have a micrograph like that, 2 slices per row mean the slice will be somewhere here, going vertically. So we will have 1 slice and second slice like that. If it's per column, so the slices would go like this horizontally. Okay. Now let's continue. Let's leave it by default. And now, because we've selected here, draw the line, we are prompted with an information to set the scale for the image, and there are some hints which are worth to read. As I mentioned in the user manual, it's worth to read all the content that's in the boxes that appear. So it says hold shift to draw a straight line of a known length, and then click OK. Hint 1 is to presenting what controls can you use to zoom in or out from the image, and second hint is to is saying that if you draw a line, you can also move it manually using the arrow keys. Okay, so on the image I will try to zoom in using Control and mouse wheel to that scale. And now I'm holding Shift button and pressing left click of my mouse. I'm drawing a scale. Okay, let's say it's quite accurate. So I will click OK. And now the program asks, you have drew a line distance of 36.5 pixels. So what is the known distance for the drawn line? And by default, again, we are given that it's 2 micrometers, as we can see, 2 micrometers. Maybe we want to analyze using different scales, so we will change that information and change this value. But for now, it's accurate. So we click OK. And now, second step is remove the label. These hints are actually the same. It's just that now we have to mark an area, so not draw a line, but mark a rectangle area. You see the program automatically selects the rectangle tool. So first of all, we have to zoom out of the image using, for example, Control and mouse wheel. And now we have to select the rectangle, which has to mark only the area which we want to analyze. And if you want to be precise, I recommend zooming in again and fixing some of the selections. And now it's fine. As you see, now if I click OK, this area will be removed. Okay, and it was analyzed actually automatically after that, as we weren't required to perform any settings. So now, because here in this menu I selected preview selected particles before the analysis, I'm asked if I'm satisfied with the particles selected for the analysis. So as you see on the left side of an image, I got the particles which were selected and will be considered in the further calculations. On the right side I have the original, so I can compare if I'm satisfied with that. And as you see, now I will explain that the other things that we've chosen. Removing small particles outliers from the image basically removed these small bits which you can see somewhere here, and some of them that weren't removed were removed automatically by specifying the minimum size of the particle analysis. And same with excluding an edges. As you can see, there are no particles on the edges of the image which will go beyond that. Some of them maybe are touching almost the edge or the corners, but they are not going beyond that. There must be some space between the boundaries. So in this example, let's say that we are not satisfied. We want to specify the particle parameters again. If you would leave by default like this and you would like to continue analysis, it will just go into the other options. But let's say that we are not satisfied. Maybe in this scenario we will select a little bit higher minimum size. Maybe some particles are not our desired option. So we will select no and click OK. And now we have another window, new interparticle specifications. So it is the same option as you've seen here, just without this checkbox, because that's what's actually done right now. So again, the default values will be always same like in the beginning window, but in this case, let's select, for example, minimum size to be a little bit bigger, so we will get rid of some of the particles. In maximum size option, by the way, it doesn't, the infinity is accepted, as you see, it's accepted as a text, but you can also input a numerical value, like for example 2 or 3, but I don't see a reason for now in reducing it in any kind of analysis. So we'll click OK. And now if you compare the size of the particles, you may go back in the video a few seconds, you will see that there is less of the particles selected. There is the particles are actually bigger usually. So this time we will say, yeah, we are fine with the size, so let's continue it. Let's click OK. And now the cluster indicator option is because of we've selected cluster indication here. So by default, you may leave it like it is and use the centroid method if you would like to do it faster, because this feature can take a little while. Let's see how quick it is. And you don't have to worry about these windows. They will open and close by itself. Just wait for another window which will ask you for specifying another settings. So the area distribution plot was just calculated before that. As you've seen, there were some of the plots which were saved. You don't have to worry about them. You will have a view on them. And now the next window is about maximum neighbor distance, because we've selected interparticle distances. So maximum neighbor distances taken to calculations in micrometers. We have to specify the numerical value here, and 1 micrometer by maximum means, for example, if we consider this particle, it will only consider the distances from this particle which are not above 1 micrometer. So for example, maybe from this particle to this one there is 1 micrometer, but to this one it's almost 2. So it will not calculate this distance, it will not include it in the results, it will not mark it on the image with saved distances. So by default, I also think that 1 micrometer is a nice specification. And also take a note on that, important. Unfortunately, the next window cannot be automated. To correctly run the calculation in the next window, specify the same number, I mean this number, and mark all the 3 checkboxes. It's because the next feature, analyzing interparticle distances, unfortunately cannot run on its own, and you have to specify the values again. and I also need that value. The script has to record it somehow. So it's best if you can actually copy that. Maybe just right click and copy, or select it and press Ctrl C on your keyboard if you are on Windows, and then click OK. And this is the window which, as I say, unfortunately cannot be automated, but fortunately you can specify where the distance has to be calculated from. Is it between the edges of the particles, or you can also select centroids and center of mass. And this is, we've selected in the previous window the value of 1, and here by default it's 10. So we have to change it. For example, I've pasted 1 using Ctrl V shortcut, or you can just simply type it using your keyboard. And the previous window also mentioned to select all these 3 checkboxes for the best results. So we want to have the lines shown, we want to have labeled the distances to see the number on the line which will be drawn, and show the matrix, calculation matrix. So as you see, this image is actually not the outline image, it's the masks image. So this image will be also saved, and it's easier for the program to mark the distances. Let's click OK, and let's wait a little bit, because calculating interparticle distances may take a little while. But our script is still quite fast. And as you see, this is the success window, which mentions that everything performed smoothly, and we are informed how long did it take to run all the actions in seconds, and then this time is calculating that how long does it take only to run the automatic part of the calculations. And also there is a nice information about if we forget where we save the results, it will be mentioned here where to look for it. And then we also have another input which we can specify if we would like to run the script again, and we can select 3 options. We can not run it, so it will simply close Fiji script that we run at the moment, or we can continue with single file analysis or the directory. So in this case, I would select to yes, analyze directory of images, because we've just analyzed a single file, but I want to show you how it will deal with directory of more images. Okay, but before that, I will also show you what are the outputs. So the outputs were saved in the results folder, as you see, and includes the timestamp of the analysis, so when it was performed and at what time. And as you see, now I will a little explain. The results means that it saved this CSV file with all the results. Summary, save the summary of all the calculations. Then these are the images that were saved: masks, outline, process, analysis, specifications, specified mainly what were the specifications, what did we input into the analysis, where did we output the results, how many images were there, what was the date, what was the time, what were the preferences, what scale did we use, what was the minimum size, maximum size, as you see, and running time. So it might be quite useful in calculating some of the things. Okay, and then as you see, clusters folder consists of the cluster indication option was selected. You can see the clustered parts, so marking areas where it met the requirements that we've specified in the previous window. Then interparticle distances, it may be of our main interest, interparticle adjacencies. So as you see, the results marked from the edges are not exceeding 1 micrometer. Like there we have the maximum distance, but we cannot find anything above that. We won't find at 1.1 or 1.2 because this was what we wanted. As you see, this distance must be longer than 1 micrometer, so it's not taken into the analysis. And the plots are marking the area distribution of a different plot. You can always read the name of the file. It also says a lot about it, like for example distribution plot of slice number 1, and here we have that slice number 1. We can take a look on it. That's what was taken into analysis, and that was the distribution of it. And if you want to use these results into, for example, different program, you can find them in the distribution plot bin values file. And if you want to just select the overall image and how it was separated, you see this montage file marks the line and marks the number of the slice. So you can include it in your paper. Okay, I think that's all what was saved. Now let's continue with multiple files analysis. Choose the input directory. So now we cannot select a single file. Like for example, if we go into test data, there's nothing to select because you have to select purely this directory. And in this directory, I've also included some file which could mess all the running of the program, but it actually checks for the extension of the file. So this is TIF, this is TXT, so it will be simply ignored. Okay, it also works with single file analysis. I will show that later after running the script. Okay, so we select the okay, now test data, select output folder, again the results folder, maybe prior to analysis I will remove any results so to see which files will be saved. Now the folder is empty. Let's leave the results selected, and if it comes to the analysis, maybe this time to run faster, I will select the fastest options which will work fine for the image. So let's use predefined scale, let's not preview the selected particles, and let's run the most basic analysis. So let's leave it like that and click OK. And again, we are asked which images would you like to save. As you see, we then select these 3 checkboxes, so now we can save only these 2 additional images. Let's save them in this run. As you see, it analyzed so quickly 2 of the images, and again, it's the same window. And as it says, it only took 5 seconds, almost 6, for analyzing automatically, for segmenting the image, for opening the results and saving them. In this scenario, we will actually select to analyze now single file. So I will present how it deals with the different kind of files and what it will show like. So select the input image, and let's now select the text file. If we select that, we are having an error function which says the input file is not an image. This is the directory of the file, and as it says, please specify a different file. Would you like to run the script again? So in most of the cases, probably yes. Maybe you've clicked by a mistake on a different file which is not an image, but in this scenario we will click no. We are done with all the analysis. Let's click OK. Now, as you see, most of the operations were done, and this is the results folder of analyzing multiple files. Each separate file, as you see, along the build 20 and along the build 21 has own folders, and their results are there, but the analysis info file, which will have the same information, and it will actually mention that we've analyzed a directory. As you see, the directory consisted of these files. These are files in the input folder, but there were only 2 images from these files along the build 20 and along the build 21. And yeah, I think that's all about using the system. In the next videos, I will talk about adding features, getting support, and handling errors. And in the last video, I will present how to quickly use the system and how much does it take for me. And yeah, so that's all. Cheers.